I am Vineet Kumar Sinha from ABES Engineering College, Ghaziabad. In this video lecture series, we are discussing the subject Materials Engineering, and we are discussing Unit 5, that is non-destructive testing. The topic for today's discussion is magnetic particle testing. So as per the syllabus, we'll be discussing magnetic particle testing. This is a technique of non-destructive testing. Also, we'll be discussing ultrasonic testing and acoustic emission testing. So, magnetic particle testing is suitable for the detection of surface and near surface discontinuities in magnetic material. The conditions are material should be magnetic and also only surface and near surface discontinuities can be detected. Mainly ferrite steel and iron, which are ferromagnetic material. What is the principle of magnetic particle testing? Here in the first figure, this is the first figure, the magnetized metal has no crack. There is no any crack is there inside the surface. So if we apply magnetic field to it, and there are only two poles, that is north pole and south pole will exist, and outside of the same, the magnetic lines will travel from north pole to south pole, and inside from south pole to north pole. The circuit will get complete. But in second figure, if suppose there is a crack or there is a gap in the surface of the uh, material or the magnetic material, and so the magnetized metal has a crack, and at the crack point there creates another north and south pole for the magnetic flux leakage. So here another north south pole would be created. So here this south will create, and here will be the north will create. So we can detect, and we can have an indication that there is a leakage of magnetic flux or there is a crack over there. So we can see magnetic particle testing in gas pipe welding. The cluster of these magnetic particles, here this cluster of magnetic particles is indicating that there is a leak or there is a crack in the joint or in the weldment. There is a crack at the C. So particles make a cluster at the welding joint for magnetic flux leakage because of welding defects. What are the advantages of magnetic particle testing? It is principally and relatively simple method. It is very economical and easy to perform. It is very portable for field testing. Very easily it can be tested. It's very fast for production testing. Very quick method, and easily we can have this done. Reveal or disclose small surface flaws or cracks which may be tight. Otherwise hidden may not be detected, but it can disclose smaller surface flaws also, and smaller flaws and cracks also. Limitations. What are the limitations? That material must be ferromagnetic. If the material is not ferromagnetic, then we cannot apply this magnetic particle testing. Orientation and strength of magnetic field is critical. There should be sufficient strength of magnetic field, and orientation should be in the correct direction. Detect surface and near to surface discontinuities only. This is also the limitation, not inside at the depth of the surface. It cannot be detected through magnetic particle testing, and surface and near to surface continuities can only be detected. Large currents are required, the current values are required, so setup would be stronger, and it will take time and cost and energy. Coming on to next testing method, that is ultrasonic testing. Ultrasonic testing. What are ultrasonic testings? A typical UT system, ultrasonic system, consists of several functional units. Several functional units is required. for ultrasonic testing, such as pulsar receiver. A pulsar receiver will emit, produce high voltage electric pulses. Piezoelectric transducer and display devices would be required. A pulsar receiver is an electronic device that can produce high voltage electric pulses, and driven by the pulsar, the transducer generates high frequency ultrasonic energy. So the electric pulse would be converted into high frequency ultrasonic waves or ultrasonic energy through this piezoelectric transducers. Piezoelectric transducers are used. The sound energy is introduced and propagates through the material in the form of waves. So the sound energy of the ultrasonic waves is introduced and propagates through the material in the form of waves. When there is a discontinuity, such as a crack in the wave path, part of the energy will be reflected back from the floor surface, and how much time elapsed we can calculate from the how much time it takes to reflect it back and to collect at the initial point. We can say that at what distance the crack is there. The reflected wave signal is transformed into an electrical signal by the piezoelectric transducer and is displayed on the screen. So two types: the pulse echo method, where the oscilloscope or flow detector scheme, the a simple setup of ultrasonic testing is like this. The piezoelectric transducer is the probe which is uh, applied to this plate, and this if there is no crack, the pulse will go and return from the last point, end point. And when there is a crack, it will go and return from the crack itself. So for this to travel this distance, the time would elapse would be less than this. So according to time elapsed, we can say at how much distance this crack is there. So the typical setup, the on the display screen, flaw detector screen or the oscilloscope, the crack echo would be achieved. This crack echo, this echo would be for this crack available here. For this crack, and this back surface echo is for hitting from the back. Another method is transmission method, where two separate transmitter receiver are applied. So sound beam is propagated through the test piece, through the transmitter, and collected at the other end through the receiver. So through transmission is obtained and sound path is measured. And again, it is displayed. Ultrasonic measurement techniques. Here we can see how it can be done. Advantages of ultrasonic testing. Thickness and length up to 30 feet can be tested. Position, size, and type of defect can be determined. Instant test results can be obtained. It is very portable. It's capable of being fully automated. Access to only one side is necessary. Access to only one side may be necessary. Only one side is also enough for the pulse echo type ultrasonic testing to be done. What are the limitations of ultrasonic? What are the limitations of ultrasonic testing? Considerable degree of skill necessary to obtain the fullest information from the test would be required, and also very thin sections can prove difficult to measure, because sufficient time should be there to come back to come and to get back the sound waves. Other type of emission testing, non-destructive testing, is acoustic emission. So acoustic emission is the phenomenon of radiation of acoustic waves in solids that occurs when a material undergoes irreversible changes in its internal structure. So whenever stress is applied to a body or to a material, there is a change in its internal structure and irreversible changes happens. And for example, as a result of crack formation or plastic deformation due to aging or temperature gradient or external mechanical force, there would be a internal change in the internal structure or irreversible change in internal structure, which causes a acoustic wave generation inside the material. So a typical setup of acoustic emission testing is like that. Suppose this material, and if a crack is, if a crack happens here, it will emit a acoustic emission, natural acoustic emission. This is sensed by the transducer. This signal is received by transducer, and it is pre-amplifier. Through a pre-amplifier, the signal gets amplified and filtered and further amplified. And this signal conditioner and event detector will cause it to show parameter after having parametric inputs, computer data storage and post processor. It reflects the total how much emission testing, how much emission is measured will say how much crack is there in the surface. So here the two, three conditions must be met. First is the loaded structure and cracks are formed. The structure must be loaded. Unloaded or structure having no stress will not cause any acoustic emission and no analysis of any crack or uh, previously and it cannot be detected. Similarly, the oscillatory movement in atoms and molecules happens due to the loading of the structure and also generate the elastic stress wave in the sample and come out. So this is a typical setup of acoustic emission testing. What are the conditions for AE? Load, there must be certain load. No load means no cracks and no emission. So it cannot be detected by this method. Control load should be there. Part of the structure has to be loaded by control load, and load bearing structure, it should be loaded anyway. Inspect a big area volume at the same time, real time. It is advantage of it that very big area inspection can be done in a single examination by placing a number of sensors at different locations where could be a potential source of damage. Stress field, stress wave propagate through the sample and received by the sensors. For example, metal, micro and macro cracks initiating and propagating can be obtained. Microdynamical events such as twinning or slip, it happens due to lattice defect, which we have discussed in the defects section also, which known as dislocation. Loaded the mechanical system, metallic system dislocation will move, and due to that movement, it creates slip. Slip is the movement of atomic planes over one another as results dislocation movement, which lead the AE. So slip causes the deformation, and this deformation causes the acoustic emission of the acoustic waves, and this is measured and analysis is being made for the and testing is done for the material. Fracture or brittle inclusions, chemical actions like corrosion can also emit emissions, radiation, the acoustic emission. Phase transformation due to change in volume and strain effect due to temperature change can also be done. The source for phase transformation, A source for phase transformation, martensite in steel at high temperature, phase called austenite is obtained. This we have already seen. When we heat it and quench it fast in liquid like water, there would be a vast emission of acoustic emission. Two phases are very different kind of property and structure, hence the volume of parent phase and transform phase are different, and due to that some stresses can be generated which may lead to acoustic emission, and subsequently we can measure the emission through setup, transducers and pre-filters and filters and screens. So this was all about acoustic emission. Further techniques or further non-destructive methods would be discussed in the next video. Thank you.